So tell me what we discussed in the last class. Huh? Like we have discussed about chemical properties of alcohols, phenols, and then next slowly we entered into aldehydes. So how can we convert alcohols to carbonyl compounds? Carbonyl compounds means aldehydes, ketones, like C double bond O should be there. So we have a table. What is the table says? How primary alcohol can be converted into respect to oxidized products. Like if I have primary alcohol, tell me how can I convert, like what are the oxidizing agents I have? Okay, I am writing here RCH2OH. See, I just wanted to give one like important notification for all the viewers who are watching it recorded version. See, first you just try to adjust the video at 1.25 speed so that you will feel little more clear and with little more speed. Otherwise, if you are watching at normal speed, you might feel like lagging. Okay, so you adjust based on your convenience, like whatever the comfortable, the way you can feel, you can adjust like that. Okay, fine. Listen here. Okay. See, now what about this alcohol? Tell me, primary, secondary, tertiary. So now primary, upon treating with KMnO4 or K2Cr2O7, what is the product formed? So primary alcohol converts into carboxylic acid, right? Then next, if I treat this with PCC or chlorine oxidation, gives you what? Aldehyde. Okay, and the next what is the other thing I have given? Even copper metal also, heating under 300 degrees Celsius, what is the product form? Aldehydes. Okay, this is done. Okay, next one, if I have secondary alcohol with whatever the oxidizing agent I can use, that gives you ketones. Secondary alcohol gives always ketones. Next, tertiary alcohols, no reaction with this oxidizing agent but converts into alkene by dehydration using this what? Copper metal. Remember that. Okay, the table we have seen in the last session. Okay, next one, after this session we have completed discussing about some important named reactions like chemical properties of aldehydes and ketones. So what is the first reaction I told you, like Rosenman reduction? What is Rosenman reduction? What is Rosenman reduction? Tell me. Aldehydes converts into acyl chlorides converts into aldehydes. So what is the catalyst used there? Lindlar's catalyst. Lindlar's catalyst means H2PdBaSO4. See here in the short form, acid chloride plus H2PdBaSO4 gives you respect to aldehyde. See, you need to remember, like whenever I say Stephen's reduction, that should come to your mind, like alkyl cyanides converts into aldehydes. Here we will use SnCl2 plus HCl, like that. Some kind of thing should be there in your mind, so that whenever you see that reaction in the exam, you can easily attempt without wasting the time. Okay, so you make this table after the class, not now. Okay, right. Next, Gutterman-Koch reaction means what I told you, benzene ring with carbonyl group, Koch carbonyl I told you. Okay, carbonyl group with HCl in presence of AlCl3 gives you benzaldehyde. Next, Etots oxidation means what? Etots oxidation means alkyl benzenes, like whatever the alkyl group is there. For example, toluene I am saying, toluene means like this now, benzene with the alkyl group. So this alkyl group converts into respect to aldehyde. So what is the product now? Benzaldehyde. Okay, so now what is the reagent used here? Chromyl chloride. What is that? Chromyl chloride. Next, Riemann-Tiemann reaction, what is that? Phenol with chloroform in basic medium like NaOH gives you salicylaldehyde, ortho product major. Instead of using chloroform, if I use CCl4, what happens? Carboxylic acid, like salicylic acid is a product formed. See, what is the difference between salicylaldehyde and salicylic acid? See, here COH will be there. This is salicylaldehyde. Salicylic acid means this is carboxylic acid. Like phenol will be there, OH. Okay, this will be the product. When it will be the product in Riemann-Tiemann reaction? When I use CCl4, see, instead of chloroform, if I use CCl4, what will be the product? Salicylic acid. Okay, remember this. Next, coal-based reaction, do you remember coal-based reaction? What happens? Phenol with carbon dioxide in basic medium gives, that's it. Next, today we will be discussing this aldol and candizzaro. Okay, then next, what about this Clemmensen reduction? Carbonyl compounds like either aldehydes, ketones with what? Zinc amalgam. Zinc amalgam means ZnHg. Zinc amalgam in acidic medium like HCl gives you respect to alkane. What is that? Respect to alkane. So what you are doing? Removing that oxygen, placing to hydrogen. That's it. Over. Everyone clear with that? Okay. So next, Wolff-Kishner reduction means same process takes place but in presence of basic medium. What is the reagent used? Hydrazine and KOH, like that basic medium under heating condition. Next, what is that? Popoff's rule. Yesterday we discussed in the evening session. Where we will be using this? Ketones oxidation. Anyways, I will revise this. Now we will start our discussion with aldol condensation once again. Okay, here we have. So now what it is saying, see once, reactions involving alpha hydrogen. It means we are continuing our discussion on chemical properties of aldehydes and ketones. Okay, some reactions are over. Now one important reaction here we have is aldol condensation. So just remember, aldol condensation means you need to know first of all about alpha hydrogen. See, this group is called carbonyl group. To this carbonyl group carbon, if directly attached hydrogen is there, that is normal hydrogen. If there is directly attached carbon is there, see this is 1, 2 we are saying, A, B I am saying. Otherwise, the adjacent one which is to this carbonyl group, this one adjacent one is there, that should be called as alpha carbon. What is that carbon? Alpha carbon. So again, if any other carbons are attached, beta, gamma, like that you extend. But our discussion in aldol condensation is about alpha carbon. What is it? Alpha carbon. See, on this alpha carbon, at least one hydrogen should be there. At least what? One hydrogen should be there. So hydrogens present in alpha carbon is called alpha hydrogens. Okay. So now let us make one compound like this. Can I say this is an aldehyde? Aldehyde or ketone? Aldehyde. Like CHO group is there means aldehyde. So aldehyde with at least one alpha hydrogen here. Means on this carbon definitely one hydrogen is required for this reaction. Okay. Now see, what happens is same compound I am taking. Okay. So aldol condensation means alpha hydrogen containing aldehydes or can be ketones reacts with in presence of dilute NaOH, dilute base. Dilute base means it can be NaOH, it can be KOH, like that, anything, CaOH twice, but it should be a dilute base. Okay. So now what happens is condensation taking place now. It means by default you should understand that aldol condensation means this aldehydes you are taking two molecules. How many molecules? Two. HCO. First I will tell you answer, direct answer with a tricky way. Then if you want, we'll go with the mechanism also. Okay. So here how many hydrogens are there? 3. Same compound I am writing once again, see. Both of them are same or not? Just our understanding purpose I have written in the other form, that's it. Both of them are same only, no? Yeah. So now, what is the main thing I want? Alpha hydrogen. See, we have alpha hydrogens now. So from one compound you take alpha hydrogen, from other compound you take oxygen. What I am saying? From one molecule you take alpha hydrogen, other molecule you take oxygen. So now how many hydrogens are there? 3. Out of that 3, I am using 2. One more is remaining, like that. So you just removing what? You are just removing water molecule. What you are removing? 2 hydrogens, 1 oxygen. H2O you are removing. What is the remaining molecule now? Tell me. C double bond O, C, H. For this one, what is the bond I should write? 2 hydrogens you are removing means 2 bonds it is making with the carbon. So double bond C. What are the groups we have here? H and CH3. Are you able to understand this or not? You are taking this molecule, how many you are taking? 2. From one molecule you are removing oxygen, from other molecule you are removing 2 hydrogens. Okay, now just join them after removing water molecule like oxygen and hydrogens. So whatever the remaining thing is there now, that is your final product. Okay, now the name of that final product should be like this. To this adjacent carbon alpha now, then next it is beta now, between them double bond is there. So what is the final product formed? Alpha beta unsaturated carbonyl compound. See, this is a carbonyl compound or not? Yes, carbonyl compound. Okay, is this clear what is happening? Just removing water molecule. Okay, for this what is required? Alpha hydrogens. Okay, now I will give you one example, then I will tell you the mechanism also, just for making you feel confident about this. You tell me what will be the answer. Tell me what is your answer for this? So how many molecules you should take? 2. Do we have alpha hydrogens in the molecule? Yes. So from one molecule you remove 2 hydrogen, other molecule you remove oxygen. So the remaining part is called your product. Now tell me what is that product, how it will be? Simple. Benzene, C, double bond, okay, double bond O, CH, double bond, C. Simple ma, you take these 2 molecules, one molecule, next molecule you take oxygen this side for comfortable writing purpose. See what I told you to remove? Oxygen and these 2 hydrogens. Out of the 3, 2 remove. So now remaining part is what? Like C, like this ring, this O as it is, and from here 2 removed, 1 hydrogen is as it is. Now what is remaining here? Double bond C. One side you have phenyl ring and other side. That's it. This is your final product. Are you able to write the product or not directly without wasting time? Everyone got this? Yeah. So now tell you now the basic definition of this. Carbonyl compounds with alpha hydrogen upon treating with dilute base gives beta hydroxy carbonyl compounds. First what they will give you? Beta hydroxy carbonyl compounds. Upon further heating, upon dehydration, upon heating means dehydration takes place. Upon dehydration forms alpha beta unsaturated carbonyl compounds. So what is the middle product we are getting before heating? Beta hydroxy carbonyl compound. What is the ultimate product? So here in these 2 examples we directly write in last product, that ultimate product. Before that what should we get? Beta hydroxy. See, beta hydroxy means very simple ma. Which one is alpha, which one is, this is alpha, this is beta you are saying now. So beta position what they have? So you put hydroxy group there, and this carbon should contain one hydrogen. From that we are dehydration. It means that OH group and this hydrogen is removed to get this product. Okay, so now what is that intermediate before forming this? Tell me. Here I will write beta hydroxy means same thing I am writing. See, try to understand this. H, C double bond O, CH, the double bond you remove, first you write with single bonds, CH3, here only we have double bond now. So now beta hydroxy means on beta carbon what should we have? Hydroxy group. So here OH group. Then on this carbon it should be hydrogen. Okay, your dehydration means you are removing this as a water molecule, like these two as water, means you are heating. After forming this product, during the reaction what is the first product formed? This is the first product formed. Okay, aldol reaction we will say. Aldol condensation means you are heating now. Heating, what happens? Dehydration. This H2O will goes out and gives you final product like this. Clear everyone? What is happening in the aldol reaction or aldol condensation? Clear or not? Any confusions are there? No. Okay. Now there I have mentioned particularly as dilute base. Now the reaction even happens with dilute acid also. With what? Dilute acid also. Aldol condensation generally, most generally you will be seeing examples with dilute bases. But they may ask sometimes, will the aldol condensation takes place in dilute acidic medium or not? Yes, it can also happen in acidic medium. Okay, remember that. Now see, product formed will be same in both acidic and basic medium. Yeah. Now what I am saying, this molecule you are taking only one molecule as two, one compound as two molecules. Now what I am saying is two different molecules I am taking, like A, B. Here I am taking only A as two times, like AA I am taking. So if you are taking like one compound only two times, you are saying it as a aldol condensation. What is this? Aldol. If you are taking two different carbonyl compounds, you should say it as cross aldol condensation. Okay, cross aldol condensation. Let us see what is this cross aldol condensation means. Yeah, see, C double bond O, H, CH3 plus they will give it like this. First condition is what? Dilute base. CaOH twice means base. Second condition is heating. It means final product will be after dehydration, alpha beta unsaturated. Up to here only they mentioned means beta hydroxy carbonyl compound. Yeah. So now tell me how many like alpha hydrogens we have? Here we have alpha hydrogens, here also we have alpha hydrogens. Yes or no? Yeah. So now try to remove alpha hydrogens first. See, why we are using alpha hydrogens first of all? This might be the question first. Because OH minus. This is a base now. So base try to abstract a proton, like acidic proton. Wherever acidic proton is there, that will be taken by base. See, now in the given compound, these alpha carbon hydrogens are there now. Those are acidic. What I am saying? In carbonyl compounds, alpha hydrogens are acidic. In aldehydes and ketones, alpha hydrogens are acidic. So why they are acidic? Try to remove that proton from here once. If you remove that proton, you are going to get C double bond O, CH2. What is the charge on this carbon now? If we are removing proton, H plus you are removing. So carbon will get negative. So this carbon anion will be stabilized by conjugation. What conjugation? See, pi bond, sigma bond, negative charge. Are they in conjugation or not? So due to this conjugate base stability, this proton is acidic proton. Everyone clear why it is acidic means? Yeah. So now this acidic proton, first base will abstract this alpha hydrogen from here or from here. Okay, let us say I am taking it from here, first condition. Okay, then now from this carbonyl group what happens? Oxygen, wherever that oxygen center is there, their reaction takes place. Like this I am writing that molecule. See, this will go and attacks at this carbonyl group carbon. Why there? Because we know carbonyl group is electrophilic center. Okay, so because oxygen take the pi bond towards itself. Okay, so now you are making a bond between this carbon and this carbon. See, so what I should write now? H, CO, CH2, this one C, CH3, phenyl ring, this O becoming O minus. Okay, now that O minus will take that the previous proton and it becomes OH. So now see, to this carbonyl group alpha, beta. So we got beta hydroxy carbonyl compound. So this is our like up to here product. Next, what is the second condition mentioned? Heating. So upon heating, what happens? From alpha position, again alpha hydrogens are acidic now, that's why this hydrogen and this OH is removed. Finally gives you, upon heating, remove water, HCO, CH double bond, C, that's it. This is your final product. Everyone got what is happening in the reaction? Okay. So now every time writing mechanism is not required. Anyways, you got the tricky way now how to do, like removal of water. From one carbon you should remove oxygen, from the other compound you remove alpha hydrogens. That gives you the final product. Okay? Okay. This is done, everyone? Okay. See, I am erasing this. That is a final product. Just keep it as a final product, that's it. See, from which compound I have taken alpha hydrogens during this reaction? Out of this, let us say this is AB. From which compound I have taken alpha hydrogens? A compound I have taken alpha hydrogens. Okay. Now we can also take it from B also, because B also have alpha hydrogens. Now tell me what is the direct final product? C double bond O, CH, remove these two hydrogens and this oxygen. After removing C, H, perfect, perfect. Got everyone? Okay. See, this is AB type, this is BA type product. Are you getting what is this AB type, BA type means? First thing, I have removed protons from here, oxygen from here, that product I am saying AB type. Second thing, I have taken protons from here, oxygen from here, I am saying this as BA type. Okay, what is the name of this reaction? Simple aldol means only one compound will be there, that self react, but here cross now. Okay, now they will ask how many possible products during a cross aldol reaction they will ask. You got only two now. Now just imagine A can also combine with itself. I am saying possible number of products. A can combine with itself also. So AA type product you will get, BB type also you will get. So totally how many you are getting? Four possible products. Yes. What is your confusion or any doubt? Anyone? See, you just imagine you are in the lab. This is a reaction mixture. In this reaction is taking place. Now in this you have A and B, both of them are there. So now there is a possibility for A to combine with itself, yes or no? You will get this kind of product. You cannot stop whether they combine or not, you cannot stop there. B has a possibility to combine with itself, so you will get this kind of product. Now A has a possibility to combine with B, you will get this kind of product. Now B has a possibility. So like that, how many cross aldol condensation products possible? Four. Clear everyone? Clear or not? Yeah. Okay, fine. Okay. What is the next reaction they are saying? Intramolecular. See, intramolecular means, cross means you have seen different molecules. Normal means within the molecule, with one molecule. Intra means like within one molecule only two aldehyde groups or two carbonyl groups will be present. For example, you just take this one. Do ozonolysis for this. See, like this you are going to see in the exam. What is your final product? B they will ask, or what is this A and B they will ask. So how to identify? First step everyone knows, what is it? Break the double bond, insert oxygens. Right now? So write that product, write this A product. 1, 2, 3, 4, 5, 6. So 6 members, see, previously it is a cyclic compound. Now you are breaking, that means it becomes an open chain compound like this. How many carbons are there in that open chain now? 6. So it becomes hexane diol like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. See, 5, 6. 6 carbons are there or not? So if you break, you are going to get this or not? Are you able to identify or not? Yeah, done. This is our A. Okay, after this, what they are doing? Treating with dilute base. So from where it will take the proton, tell me? See, both sides it is same. Identify alpha position. Perfect. The second position is alpha with respect to this carbonyl group. Fifth with respect to the sixth carbon. So here 2 hydrogens are there. Here also 2 hydrogens are there. Okay. So now just consider, from wherever you remove, product will be similar, because from both ends it looks like same structure now. Yeah. So from one side of the carbonyl group you remove 2 hydrogens, other side you remove oxygen. What happens now? Between which carbons it is forming a double bond? What we know, the tricky thing what we did, oxygen from one carbonyl group, alpha hydrogens from other carbonyl group. So let us say from here I am removing alpha hydrogens, here oxygen. So remove this part. So you are making a ring now again between 5 and 1. So 1, 2, 3, 4, 5. You are going to get a 5-membered ring. What is this? Like this. Try to number it first. Number it first. Let us say this is 1, 2, 3, 4, 5. Okay? Numbered, done. Between which carbons making a double bond now? Let us make the double bond here. Okay. Next, after this, on 5th carbon, what we have extra group? You put that here. That's it. That's it now, or any other group is missing? Same now, that's it now. So now check, this is alpha, this is beta. Alpha, beta, unsaturated carbonyl compound is formed or not finally? So this is our final product. This is your final B. So this is how most generally questions will be asked in the exam. Okay, some part is hydrocarbons part, some part is like aldol condensation reaction. Okay, so you got this everyone? Intramolecular aldol means within the molecule we have, see, within this molecule only both beta hydrogens are removed, alpha hydrogens are removed, oxygen is removed. That's why we are saying it as intramolecular aldol condensation. Okay, done. Next, if you want you can write. Okay, you can write later. Next one, Cannizzaro reaction. See, what is that condition there we seen? Here should not be contain any alpha hydrogen. So now tell me, I will write 4 compounds which will show Cannizzaro reaction. First compound, so which are the following shows Cannizzaro reaction? Cannizzaro reaction. So tell me. Huh? Multiple answer it is, multiple selective. See, what is the primary like condition to be considered? Cannizzaro reaction means without alpha hydrogens carbonyl compounds. It means carbonyl compound should not contain alpha hydrogen. So tell me, first one, does it have? So it will show Cannizzaro reaction. Next, second one, no alpha hydrogens na, so it will also show Cannizzaro reaction. Third one, alpha hydrogens are there na, so it will not show. Alpha hydrogens are there, so it will not show Cannizzaro reaction. I am saying about shows. Next, what about this fourth condition, fourth compound?
6 alpha hydrogens show.
How many alpha hydrogens? Does it have alpha hydrogens or not?
Yes.
Where it is? How many it is? One alpha hydrogen is there, but due to these bulky groups, this molecule also shows Cannizzaro reaction. It means due to these bulky groups, this proton cannot be abstracted. ఇప్పుడు ఆల్ఫా హైడ్రోజన్స్ ఉంటే ఏం జరుగుతుంది? Aldol condensation reaction should take place. Here we have alpha hydrogen, but it cannot be abstracted by base. Why? Because of this bulky groups. Therefore this compound also shows Cannizzaro. Is this clear or not, everyone? Okay. What happens in Cannizzaro reaction, tell me? Without alpha hydrogens, carbonyl compounds without alpha hydrogens, upon treating with concentrated NaOH, KOH. Okay, now here you should not say this as a base. NaOH, so I should call it as base. No, here you should not say it as base. In Cannizzaro reaction, NaOH acting as a nucleophile. How it is acting? Nucleophile. See, what makes the difference between base and a nucleophile? Base means takes the proton, like accepts a proton. But nucleophile attacks on the electrophilic centers. It will not go to what? H plus ion. So just listen here what I am saying. I will show the difference. look at this basic difference between a base and a nucleophile. See, here HCl is an acid you are saying. Now what it will do is this OH minus from NaOH, this OH minus only takes this H plus ion, right now? So if OH minus taking H plus ion, then you should say this as a base. But in this case, OH minus will not be taking any H plus ions, will not be taking or reacting with any acids. What it is doing, it will go and attacks at this carbonyl center. So carbonyl center means electrophilic center, no? So if OH minus is attacking on any electrophilic sites, you should say it as a nucleophile. If it is taking a proton, you should say it as a base. This is a very small thing you can expect in vivas or any interview questions like that. Okay, very basic. Ardhamaindi andariki? Okay. Okay. So let's remove this. Okay. So tell me, does a given compound contains any alpha hydrogens? No. So it means it will not show aldol. So now it will show Cannizzaro reaction. So in Cannizzaro reaction, simple. Hello everyone. What happens? This compound, like this molecule, this compound you are taking now, consider two molecules by default as we did in the aldol condensation. Okay, how many you should take? Two. So HCO, please listen, in 2 minutes you will get the answer. Like this you take two molecules. Okay, this OH minus is there now. It will be taken by one of these molecules. Mana daggara enni unnai? Two unnai. One of this molecule will take OH minus. And if it is taking OH minus, H comes out. What happens? If this molecule will take in that OH minus, you add that OH to this compound, HCO. Now what I should write here? OH plus. You are giving this OH minus here now. So what will comes out I am saying? H. That H is taken by other molecule. You give it to this one. Now how many hydrogens comes to this? Two already there, that new one. Totally 3. Two already there, one new. So it becoming totally CH3. CH3. Next O is there. It becomes OH. So in in Cannizzaro reaction, one compound or one molecule get oxidized, other molecule get reduced. What do we mean by oxidized and reduced? To this molecule you are adding oxygen. Addition of oxygen means what? Oxidation. To this another molecule you are adding hydrogen. Addition of hydrogen means what? Reduction. So what happens in Cannizzaro reaction? One molecule get oxidized, another molecule get reduced. Okay, so what are the final products you should say? Carboxylic acid and alcohol. Everyone, what is the products? Carboxylic acid and alcohol. Okay, everyone got this? Yeah. Now tell me what will be your answer for the next question. Easy, easy. Tell me what is your answer for this? Huh? C double bond O OH plus next. Okay. C CH2 OH. Are very simple. దీనికి ఒక హైడ్రోజన్ తీసేసి OH యాడ్ చేయండి, దట్ విల్ బి యువర్ కార్బాక్సిలిక్ యాసిడ్. నెక్స్ట్ దానికి యూ జస్ట్ యాడ్ ఇక్కడ తీసేసిన హైడ్రోజన్ దానికి ఇచ్చేసేయండి. సో ఇట్ విల్ బికమ్ CH3OH. సో యూ ఆర్ రిమూవింగ్ వన్ హైడ్రోజన్ ఫ్రమ్ వన్ మాలిక్యూల్, గివ్ ఇట్ టు ద అనదర్ మాలిక్యూల్, ఇట్ బికమ్స్ one hydrogen is there, now it becomes two hydrogen. So CH2OH, alcohol carboxylic acid. Clear everyone? Okay. Now look at this mechanism also. OH minus. See, do we have any acidic proton in the given compound? Any alpha hydrogens are there? If alpha hydrogens are there, this OH minus react with that alpha hydrogen, gives you aldol product. But there is no alpha hydrogen now, now it will attacks here. So this oxygen converts into O minus. So HCO minus HOH. Like this it will be getting. Okay. So after this, oxygen with negative charge we have now, so it will comes back to its original site. When it is coming back to its original site, already 4 bonds are there. If this bond comes, it becomes a 5th bond. 5 bonds cannot hold by carbon now, so one of these attached groups should come out. Which groups come out? H plus or H minus? See, from here electrons are given now. Already 8 electrons are there. If you are giving these electrons also, 10 electrons it becomes. Now what should be removed? H minus. Okay. See, you might have whether I should remove OH minus or H minus. You are doing the reaction in basic medium now, so that's why this OH minus won't comes out. Now which ion will be there? Only H minus. So what is coming out? HCOOH, and which is coming out? H minus. Now what I told you, this H minus will attack on another molecule. So like this, how many molecules we are taking? One molecule get oxidized to carboxylic acid, another molecule here it is simply sitting. That molecule reacts with this hydride ion. Like this it will be attacking HCO minus H. So see, all 3 groups are same. So it will not get back here because all of them are same now. Yeah. So now finally what I am saying, this is nothing but methanol, no? Methoxide ion, no? CH3O minus we have. So this minus, see this is an acid. What this acid will do? Gives H plus ion. That H plus ion is taken by, so it converts into CH3OH, and it will be HCOO minus Na plus, carboxylate ion and methanol. So what are the final products in Cannizzaro reaction? Carboxylic acid, alcohol, or carboxylate ion and alcohol. Carboxylate ion and alcohol, remember that. So one is getting oxidized, another one is getting reduced. Okay. Now look at this. Okay. So now what is the product formed? Just previous to this, we discussed about intramolecular aldol condensation now. Similar to that, within the molecule we have 2 aldehyde groups. So do we have any alpha hydrogen? No alpha hydrogen. And here concentrated NaOH is given. So what is the reaction? Cannizzaro. Within the molecule both compounds are there, means intramolecular Cannizzaro reaction. What is that? Intramolecular Cannizzaro. So now one should undergo oxidation, other should undergo reduction. Now out of these 2, which will undergo oxidation and which converts into alcohol? Yeah. So yesterday I told you about nucleophilic addition reactions, if you remember. So nucleophilic addition reaction is more reactive when we have electron withdrawing group. Yeah. So now if you observe, nitro group is withdrawing or releasing? Withdrawing. And we know this withdrawing nature will be more at ortho, para or meta. Which position? Ortho and para. It will not show any effect at meta. So there is no mesomeric effect at this meta. See, with respect to this is a meta position now. So now tell me, it means this electron withdrawing nature shows only at para but not at this meta. Why not it? Because mesomeric effect won't applicable at meta position. So it means out of these 2, which is more electrophilic now? Para 1. Why para 1? Because this is electron withdrawing group, withdraws electron towards itself from this carbon. So which is electrophilic now? This is more electrophilic. So the more electrophilic carbon will be attacked by this nucleophile. It means this will convert into carboxylic acid, this will be converts into alcohol. So now what is your final product? Tell me. this becomes C double bond O, O minus Na plus, and this side becomes CH2OH. This is your final answer. You got how to decide which is undergoing oxidation and reduction? Just simply based on what? Electrophilicity of this carbon, of the carbonyl group, and this nucleophilic attack, that's it. Okay, that's it. You can write this example. So what are the two nucleophiles you have seen Cannizzaro reaction? One is OH minus ion and another one is H minus ion, because H minus attacking here now. So what are the two nucleophiles in Cannizzaro? OH minus ion, H minus. Remember this. Okay. Next one. Okay. Next, oxidation of ketones. Yesterday we have discussed this. Generally, oxidation of aldehydes gives you what product? Oxidation of aldehydes gives you what? Oxidation of aldehydes. See, aldehydes means RCOH. Like this now, you are oxidizing this means you just need to add oxygen, not hydrogen. If you are converting into alcohol means what you are adding? See, only one hydrogen is there previously. You are adding more hydrogens. It means this is called a reduction. Conversion of aldehydes to alcohols means it is a reduction. Now what I am saying? Oxidation. So for oxidation purpose, some oxidizing agents will use, and that converts carboxylic acids. Carboxylic acids are formed upon oxidation of aldehydes. Now when we are doing for ketones, do we have a hydrogen like this in the ketones? No, because both sides alkyl groups only we have. Okay, so that these ketones are less reactive towards oxidation compared with the aldehydes. So that we require strong oxidizing agents. What are the strong oxidizing agents we are using? Like KMNO4 or concentrated nitric acid. So now you are using concentrated nitric acid or KMNO4 now. Under this condition, molecule breaks into two equal halves. Molecule breaks into two parts. So where to break means you need to break in such a way that the carbonyl group carbon goes with least carbons containing alkyl side. This side how many carbons are there? 1. This side how many are there? 1, 2, 3. So which alkyl group is smaller? This one. So your carbonyl group should go with this smaller alkyl group side. So I can break here. If I break here, write this one CH3 O, convert this into OH. You are breaking here now, this becomes OH. What about this carbon now? Same, 1, 2, 3. So how many carbons are there? 3 carbons. 1 carbon, second carbon, third carbon. Convert that also into carboxylic acid. So ketones also upon oxidation gives you what? Carboxylic acids. But how can you decide the product? Break the molecule right to carboxylic acid, but the carbonyl group the ketone carbonyl group is there na, that goes with the smaller carbon like alkyl chain side like this. Okay, you got this? Okay, so if it is clear, just answer me this one then. Which side? Like this or like this? A, B. Which side? B side I should break. So what is this product formed this side means? CH3, CH3, C, double bond O, OH. Acetic acid is this one. Next this one is what? 1, 2, 3, 4, 5. So 5 means pentanoic acid. What is that product? Pentanoic acid. Clear everyone? Okay. This rule is called Popoff's rule, like breaking small side carbonyl group going all these colors. What? Popoff's rule. Next. Next one is we have aldehydes, ketones, right now. So how can you distinguish them? Aldehydes and ketones. We have some tests like Tollens test, Fehling's test. Have you heard this word? Yes. So now both Fehling's test, Tollens and Fehling's test, both gives confirmation for aldehydes only. The test is shown by which compounds? Only aldehydes. What I am saying, Tollens test and Fehling's test. These tests are given by what compounds? Aldehydes only. Okay, it means I have ketones and aldehydes. Who will give the test? Aldehyde. Okay, so now particularly when I say about Fehling's test, it gives aliphatic aldehydes only. It gives test for what? Aliphatic aldehydes. Okay, it means for example I have some compounds. You just tell me. Writing 4 compounds. Yeah. Tell me first compound. Okay, let us keep it aside. What about this one? Will the test will be shown by this compound or not? Fehling's test? Fehling's test is shown by this compound or not? Check whether this is having aldehydic functional group or not. What is that aldehydic means? What? C double bond O H. Do we have this fragment in the molecule or not? Yes, now remember, it can be any compound if it contains this fragment can show this test. Fehling's test and Tollens test. Again, Fehling's test is given only by aliphatic, not by aromatic. Now tell me whether this compound gives Fehling's test or not. Yes. Tollens test. All types of aldehydes gives you Tollens test. Now tell me whether this is aldehyde or a ketone. Aldehyde. So tell me whether it shows Tollens test. Tollens test. Yeah, Tollens test is shown by all types of aldehydes, but Fehling's test is shown only by aliphatic. Now tell me this one shown by both Tollens as well as Fehling's. What about this compound? What about Tollens test? Tollens test is shown by all types of aldehydes. Fehling's test is shown only by aliphatic. Now tell me, keep it aside. First you tell me about this compound, this last compound. Tell me whether it is aldehyde or a ketone. Ketone. Tollens test? No. Fehling's test? No. Clear now? Tell me with this now. Tollens test? Yes. Because this aromatic ring is there now. So it is benzaldehyde, aromatic aldehyde. Fehling's test is not given. It gives only. Clear everyone? Identifying Fehling's and Tollens test, aldehydes, ketones. Okay. So now what do we mean by Tollens reagent? Tollens reagent means ammonical silver nitrate solution. What is that? Ammonical silver nitrate solution. Silver nitrate solution. Okay. Now it will be just represented with a simple complex also. NH, Ag, NH3 twice plus OH minus also it can be represented. Or it can be given like this also. AgNO3 NH4 OH. Like this also they may mention. They mention with the writing name, simply writing Tollens reagent or with this complex or with this composition. All of them indicates what? Tollens reagent. Okay. Fehling's test is, they just mention Fehling's test, that is nothing but cuprous ammonical cuprous sulfate. What is it? Copper sulfate, like CuSO4 you can write. Okay. So here we have two things, Fehling's A, Fehling's B. So both can be considered here. What they will give? Like copper sulfate means here what is the oxidation state? +2. Right now that will be converted into +1 oxide. Cuprous oxide will be formed. So what is the color of this cuprous oxide? Red PPT. So it means if there is an aliphatic aldehyde, after adding Fehling's reagent, you will see a precipitate. What is the color of that precipitate? Red. By this you can say the compound is aliphatic aldehyde. Okay. If there is no change, means may not be aldehyde or may not be aliphatic aldehyde, you can say. Okay. Tollens test, if you put this silver is there now, that will be precipitated as like silver metal will be formed. Okay. So now what it will be? Like a silver mirror will be observed. What it is indicate? The given compound will be aldehyde. It cannot be a ketone, it can be a aldehyde. Next, iodoform test or haloform test. What is the next test? Third one. Listen this carefully. Haloform test or iodoform test. You know chloroform? What is the formula of chloroform? CH. You are saying chlorine means chloroform. If there is bromine means bromoform. Iodine means that is what this one. Iodoform they will mention. Okay. So now this iodoform test is given by carbonyl groups having methyl as a alpha position. What is the mandatory fragment we require? It can be ketones, aldehydes, but they should contain what? Methyl group. What group? Specifically what group? Methyl. This side whatever it might be, but one side of this carbonyl group must contain what? Methyl. They gives you this haloform test. Okay. Once again, which type of compounds will give haloform test? Methyl group containing aldehydes, ketones gives you haloform test. Okay. Right. So what happens? For example, CH3, COH. Will this compound gives haloform test or not? Tell me first. Because it contains this. Yeah. Will this compound give haloform test or not? Why? This side we have methyl only, no? This side ethyl. No matter, at least one side we require what? So we have, it will gives. This compound will give or not? No, because both side is ethyl, no methyl is present, so it won't show. Clear everyone? Simple way of understanding or identifying. Okay. Now you are treating this with chlorine in basic medium or see, chloroform means chlorine I can take. Iodoform means I should take here iodine, or simply any halogen means X2 you can confirm. Okay. In the question they will mention like this compound here X2NaOH, they will mention like this. So into your brain what should be the concept should get? Methyl hydrogen we have, so definitely haloform reaction. So in a haloform reaction what happens is this methyl is there now, directly you remove, take it out, you are bringing here that carbon. Okay. If they mention iodine, you write it as iodoform. If they mention chlorine, you write it as chloroform. Like this. Clear up to one part? What is the mandatory thing we require? Methyl group. You bring that methyl, write it respect to iodoform, haloform, whatever it might be. Okay. Now the remaining portion is there now. To that you give this OH. What will become now? HCO OH. Clear or not what is happening in iodoform test, haloform test? Once again. Carbonyl compounds, it can be aldehydes or it can be ketone. In order to show this iodoform test or haloform test, what is the criteria? methyl group. This alpha methyl group should be there. So now you bring that methyl group, you remove that methyl group and convert into respect to haloform. Here if iodine mentioned, iodoform you write. Done up to here. Next remaining fragment is there, na? To that you give this OH minus. You will get respect to carboxylic acid. So what are the final products? One is haloform, another one is carboxylic acid. Now simply I will get an answer from you. See. Tell me what is your answer? Perfect. Benzoic acid. Benzoic acid plus C, iodine is given now, so iodoform, CHI3. So iodoform is yellow color, like you are going to get an yellow color precipitate. What you are going to get? Yellow color precipitate. Everyone got this? Yeah, perfect. Next one. Yesterday's oxidation table, if you observe, there you have written something like this. Alcohols you have written. Primary alcohols you check once. Alcohol you have written with chlorine oxidation. What is the product formed? What is the product formed? Oxidizing agent, primary alcohols converts into aldehydes. So this is the aldehyde now formed. It means if this alcohol contains a methyl group over here, so what will be the product formed? If this is the alcohol I am giving, here I am mentioning chlorine and O, this will be the aldehyde formed. So now tell me whether this shows haloform reaction or not. Yes. If this is showing, then respect to alcohol also shows. Once again, up to here ketones, aldehydes clear na? What they should contain? Carbonyl group with methyl group. Now I am slowly taking you to alcohol concept. Alcohols, those contains methyl group after oxidation will also shows haloform test. So out of all primary alcohols, what I am saying, out of all primary alcohols, only ethanol will show haloform test. Which alcohol will show? Ethanol. Out of all primary alcohols, ethanol will show haloform test. When it comes to secondary alcohol, what is the structure of secondary alcohol, you tell me? CH, OH, this side two alkyl groups will be there. Okay, out of these two, at least one methyl group is present. See ma, there are two R groups. Tell me whether this is primary, secondary, tertiary? Secondary. Out of these two R groups, at least one should be what group I am saying? Then that compound will show haloform test. Is this clear? Okay. Why it shows? Because when you are treating with halogens like iodine or chlorine or whatever it might be, so first what happens to that alcohol? That gets oxidized to respect to carbonyl compound. See, secondary alcohols converts into which form upon oxidation? Ketones. Secondary alcohols gives you ketones all the time. So what is a ketone you are going to get? See, double bond O, this side one R group and this side one R group. Now what I am saying, if any of these R group, at least one must be CH3, then this compound will also show, because it is giving first a methyl group containing a ketone, that's why it will shows. Okay, that's it. Yeah, now let us get the answers for these questions. Yeah, tell me, which of them will show iodoform test? First one will it shows? If alcohol is mentioned, convert them into aldehydes first. Aldehydes are ketones. Then if they contain any methyl group, that will shows. Yeah, tell me first one will show? First one will show or not? This is an alcohol now, methyl alcohol. CH3OH. Primary or secondary or tertiary? Primary. Like not even a carbon is there. So out of these, which type, primary means which type of alcohols will show, I told you? Only, what about this? This is ethanol? it is a methanol, so it won't show. Next, formaldehyde I have mentioned. Will it shows? Do we have any methyl group? No, it won't show. What about this acetaldehyde? This compound is called acetaldehyde. So they have this fragment or not? So it will shows. What about this one? This is called acetone. This is acetaldehyde, this is acetone. Next, what about this one? Write its structure, don't say show, not show, like that. Otherwise you will be in sleeping mode. No, why no? Write the structure 1, 2, 3. 1, 2, 3. Do we have methyl? Carbonyl group contains any methyl group direct? No, so it won't show. That's it. Next, this one 3-pentanone. Write the structure. No. Next, 2-pentanone. 2-pentanone shows. Why? This is pentane. 1, 2, 3, 4, 5. 2 means second position O. So we have methyl group this side. So last one shows. If I say 3-pentanone, it comes here. Both side ethyls only. So it won't show. Clear na everyone? How to identify haloform test? Yeah. Yeah, these are some explanations for that. Let us conclude this. First of all, aldehyde shows Tollens test. Yes. What is the product formed? That aldehyde converts into carboxylic acid. So during Tollens reagent, Tollens test and Felling's test, what happens to that aldehydes? Converts into carboxylic acid. It means what is that process called? Aldehyde to carboxylic acid means oxidation. Oxidation of that compound takes place. Okay. Next, both forms carboxylate ion, and like Tollens will give you silver mirror, Felling's gives you red color precipitate. Okay, silver mirror, red color precipitate. So methyl group containing compounds, carbonyl compounds, shows what test? Iodoform test. Iodoform test, they will form iodoform, gives this is what one? Yellow precipitate. Okay. Next, ketones upon treating with KMNO4 or HNO3. What is that rule? Small rule. Popoff's rule we discussed, no? So gives you acids. Next one, ketones with peracids converts into esters. Okay, what is this one? Ketones converts into esters means R, CO, R dash. Is this a ketone or not? CH3, CH2, CH3. Tell me, is this a ketone or not? Ketone ena idi? You are treating with peracid. Normally acids means how it will be? COOH. This is what? Acid. But it is mentioned as what? Like hydrogen peroxide. It means OO, 2 oxygens will be there. Like H, like this hydrogen peroxide means. So when I say peracid, it also should contain that peroxy bond, like this OO bond should be there. It means how many oxygens should be there? Totally 3. So its formula can be H3 CO 3H. So what is the name of this compound? Peracids. Like what is this? Peracids. Example of peracids. Okay. So now ketones with peracids. What is the product formed? Esters. Esters means what is the general formula? Tell me. R, CO, R. Like this now. So it means one of this alkyl group converts into OR. 2 alkyl groups are there, like R, R. 2 alkyl groups are there. One of this R group converts into OR. Which group? Depends on their sizes. Which is bigger size, that converts into OR. Once again, out of these 2 alkyl groups, which will converts into OR form? Bigger one. So out of this, which will converts into OR form? So I should write CH3 CO O C2H5. This is your answer. Okay. You can make this table, otherwise later you can do. Okay. Next one, we'll start discussion on carboxylic acids. Yeah. So let's start. Okay, listen. Listen. Rx I have. Rx means alkyl halides. Upon treating with magnesium, with what I am treating? This this reaction takes place in ether condition, dry ether. So what I am saying, alkyl halides, here it is not sodium, don't think Woods reaction. So it is what? Magnesium. Sodium means Woods reaction, that is perfect. In dry ether, it will forms RMgX. So what is this RMgX? It's a Grignard reagent. Now, see magnesium, what is the charge on magnesium? Plus 2. And then if it is plus 2, this our alkyl group will have -1, halogen will have -1. So carbon, like alkyl group with negative charge, let us say methyl magnesium bromide, I am saying. So what is the charge on our methyl group? So now due to this minus charge on alkyl group, Grignard reagent act as a good nucleophile. How it can act as? Good nucleophile. Or if there is any acidic proton, it can also act as a good base. It can act as a good nucleophile or it can be a base. Sir, how to decide whether it is a base or a nucleophile? See, first of all, in a given compound, if there is any acidic proton, it will act as a base. If there is no acidic proton, it will act as a nucleophile and attacks on that electrophilic carbon. Is this clear? Every time when you are doing organic reactions, if in the given compound any acidic proton is there, then that negative charge species act as what? Base first. Like first acid base reaction takes place. Then only electrophile, nucleophile, all this happens. First, what I am saying, if there is a negatively charged species attacking on our substrate, if our substrate contain any acidic proton, what happens to this one? It will act as a base. Otherwise, if there is no acidic proton, then it acts as a nucleophile. Everyone clear with this point? Okay. Now, see this. Formaldehyde I am writing. Formaldehyde with Grignard reagent, RMGX. Okay. See, what about our formaldehyde carbon? Electrophilic or nucleophilic? Electrophilic. Our Grignard reagent have negative charge now. So what it will do? It will attacks here. So it will be converts into HCO minus H. What is adding here? R. So here minus MgX plus. Like this we are going to get. Okay, this upon hydrolysis, it means you are adding water. Remove this part. H, like what is that? Carbon with 2 hydrogens and 1 R group and 1 oxygen and hydrogen from this water. So it will converts into alcohol. So it's very simple ma. Formaldehyde upon treating with Grignard reagent forms primary alcohol. Once again, formaldehyde with Grignard reagent gives you primary alcohol. Aldehydes, next aldehydes with Grignard reagent gives you secondary alcohols. Once again, aldehydes with Grignard reagent gives you ketones with Grignard reagent gives you tertiary alcohols. Remember these points, very important. Firstly, let us consider aldehyde. Tell me how many carbons are there in the given compound? Like other than this side we have 1 carbon. This alkyl group means carbon only, no? Again you are adding RMGX means this. Now RMGX contain 1 carbon. New carbon is coming here. So now converting into alcohol means R, C, R, H, OH. So finally product contains how many carbons? 2 carbons. So can I say this carbon as what? Primary or secondary? So once again tell me, aldehydes gives you what? If it is formaldehyde, do we have any carbons other than our carbonyl group? No. We are adding newly 1 carbon from Grignard reagent. So this carbon becomes it as a primary alcohol. So once again, formaldehyde gives you primary alcohol. Aldehydes gives you ketones gives you because ketones before reaction only 2 carbons are there. Now from Grignard reagent 3rd carbon is coming. What happens? 3 carbons around alcoholic carbon. What is it? Tertiary. Okay, like that you should understand. Okay, remember. So acetone is there. Acetone upon treating with Grignard reagent. Tell me which type of alcohol is formed? Tertiary, because acetone is a ketone, not 2 alkyl groups are already there. Let us say I am treating this with ethyl magnesium bromide. With what I am treating? Ethyl magnesium bromide. So which type of alcohol is formed? Tertiary. Why? Because ethyl group means this is a negative charge will be added here. So CH3, C, CH3, ethyl, OH. This is your final product now. What is the degree of this carbon? 3 degree. So ketones gives you what? Tertiary alcohols. Clear with these 3 statements? Yeah, remember that. Next, when it comes to carboxylic acids, what is the general structure we have? R, like COOH. Okay, so now if there is only one hydrogen here, what is the name of this compound? Formic acid. What is that? Formic acid. If it is CH3 group, here acetic acid. So now what is the IUPAC name of formic acid, they will ask. What is the IUPAC name of? Formic acid is a general common name because it comes from ant. Ant means formica, that's why formic acid. So they will ask what is the IUPAC name of this formic acid. How many carbons are there in the formic acid? 1. So 1 means what? Methanoic acid. Formic acid IUPAC name is what? So our acetic acid IUPAC name? Ethanoic acid. Like that you can write. Okay, fine. So again, after the class you just go through these common names and IUPAC name for different compounds. Okay, next let me check with some preparation methods. So tell me, from primary alcohols, how can we prepare carboxylic acids? Alcohols, how can we prepare? How can we prepare carboxylic acids? What to do? Yes. So it can be strong oxidizing agent. See, alcohol's conversion to carboxylic acid means oxidation. So for that purpose we require oxidizing agents like KMnO4 or potassium dichromate K2Cr2O7. Those are perfect things. Okay. Next, no, copper will gives you aldehyde. Okay, only KMnO4 or K2Cr2O7. Okay. Next, Jones reagent. These are the 3 things. Perfect. Next, if I get from like what are the products from secondary alcohols? Ketones. It won't give me. But from ketones what I can do? Ketones to carboxylic acid. Again, what is the reagent I should use? Just now we discussed. Like this ketone is given. How can I convert into carboxylic acid? Popoff's rule I told you. What is the reagent I should use? KMnO4 or HNO3. Already you studied this already there. Again it is coming. The chemical properties of ketones is nothing but here preparation methods of carboxylic acids. Okay. Next, cyanides are alkyl nitriles or C triple bond N. These upon complete hydrolysis, what I am saying, cyanides on complete hydrolysis gives you carboxylic acids. What they will produce? See, look at this. By hydrolysis of cyanides or nitriles gives you what? Carboxylic acids. And also upon amides, also upon hydrolysis gives you what? Carboxylic acid. Look at here, cyanides on partial hydrolysis first produces amides. Once again, cyanides, partial hydrolysis produces amides. Upon complete hydrolysis produces carboxylic acids. It means from here, finally what I want? Carboxylic acid I want. In between these two what is produced? Amides. So what I am adding? Water. Here also adding water. Okay. So complete hydrolysis produces, partial hydrolysis produces amides. From where? From cyanides. Remember, very important point this is. Next. Okay. Next one. CO2. Tell me, CO2 is electrophile or nucleophile? Carbon of CO2. Carbon of CO2. Electrophilic, because this bond is taken by oxygen. Now treating this with Grignard reagent. Tell me what is the product formed? Tell me what about Grignard reagent nature, nucleophilic or electrophilic? Grignard reagent. So where it will goes now? Here now. So now what happens finally? C double. R, this is becoming O minus MgX. This is salt. If I add water to this, gives you like H, you give this side R CO OH. So carbon dioxide upon treating with Grignard reagent followed by hydrolysis produces carboxylic acids. Once again, carbon dioxide upon treating with Grignard reagent produces, just say carboxylic acids. Okay. Next. Now carboxylic acids we are saying now, already we discussed about their acidic nature, like chemical properties we are now discussing. What are the chemical properties? Like they show acidic nature. So what is the order of their acidic nature? If they contain electron withdrawing group, acidic nature of carboxylic acids increases. See, now simple question is given like this. COOH, COOH. This is a PYQ question. Today only I have seen this. COOH. It's very simple, but tell me which is more acidic? A, B, C. How can you answer this? If we have electron withdrawing group, it is more acidic. Yeah, tell me in which compound we have electron withdrawing group? B and C. Why? Why? Because oxygen is more electronegative than these carbons. If it is more closer, more withdrawing. Because do we have any conjugation with this? No, no mesomeric effect. Only which effect is shown by oxygen now? Minus I, inductive. Here also minus I. But we know I effect is distance dependent. More close to the carbonyl group like this carboxylic acid, more withdrawing. So this is distanced by 1 carbon. It is separated by 1, 2. So which is closer? B. So that makes it to be more acidic. So order B, C, A. Got everyone? Yes. Like that, if we have this CF3 group on carboxylic acid, then it will be more acidic, then nitro group, then cyano, and fluorine, chlorine, like that. Okay. Now, if we have electron donating groups or releasing groups, acidic nature decreases or increases? Decreases. Releasing withdrawing groups means increases, releasing groups means decreases. That's it. See, here some examples are provided. Just check what makes a difference between them. Last here, first one is with fluorine. In the place of fluorine, chlorine, bromine. Which is more electronegative or which is minus I effect? That's why it is more acidic. Like that we have the final order. Okay? Right. In the second example, if you observe, the final compound contains how many chlorines? See? So it means 3 minus I groups are there. In this compound, how many chlorines are there? 2 minus I groups. Here only 1 minus I group. Here no minus 1 minus I group. But distance you check. Okay? So finally, which is more acidic we are seeing? More the minus I groups, that will be more acidic. That's it. Okay. So tell me decarboxylation, what happens? Carboxylic acids upon treating with soda lime
in the presence of concentration
gives you, yes. Now fast you tell me. I will give you one question on this now. Decarboxylation means what happens? Treating this with NaOH plus CaO. What is the final product? What is removed? So this CO2 is removed means what is the remaining part? RH. Now remember, in decarboxylation, reactivity order they will ask. For example, this is what? Carboxylic acid. If I do this decarboxylation, what is the product form? Tell me. CO2 removed. What is the product? Benzene only. What is the product? Benzene. Okay. Now to this benzoic acid, just to see what I am doing. Here nitro group, no group, methyl group. Tell me A, B, C, which is more reactive towards decarboxylation? Out of these three compounds, reactivity towards decarboxylation. Tell me, how can we answer this? If electron withdrawing group is there, rate of decarboxylation increases. What I am saying, if electron withdrawing group is there, rate of decarboxylation increases. So which is, you can write decarboxylation, electron withdrawing groups increases rate of reaction or rate of decarboxylation. So which is more here? A, B, C. This is the order. Okay, remember this. Next, coal base electrolysis gives you what? What type of product? This one you tell me for this. RR product now, plus CO2 gas plus H2 gas. These two are at anode. This is at cathode. Perfect. Next. Distillation of salts, calcium salts. It means calcium means what is the charge on calcium? Group 2 now, plus 2. If it is plus 2, anion should be minus 2, overall it will be neutral. Okay. So here what you are seeing, HCO O minus. Like this, how many we require? Minus 1 charge means 2. Calcium will be 1 because it is plus 2 charge. Now just imagine you are having only this one and you are doing distillation here. Now what happens? From carboxylic acid, you just write 2 parts, O minus, one more also, HCO O minus. See, we know the well-known compound with calcium is calcium, and this carbon dioxide means calcium carbonate. So what is the byproduct you are going to get? Calcium carbonate. It means with one calcium what you require, one carbonate group is required. See, if I remove this part, you are getting CO2. But how many oxygens required? 3. Remove from adjacent also. Like this. What is the remaining part? Tell me. HCOH. So what is the final product you are getting? Formaldehyde. So if it is formate ion, calcium formate, that gives you formaldehyde. Okay. Next one, if you say, so tell me what is the product formed here? Write the structures so that we'll get the answer clearly. How to say? What is the answer? Ketone. What is that answer? Like how the structure? Write it clearly. What to remove? CO3, 2 minus. Yeah. Carbonate ion you remove. Remaining part you tell me. CH3, CO, CH3. What is the name of that compound? Acetone. So you can simply say acetone as your answer. CH3, CO, CH3. How you did this? This is the thing with calcium plus 2. So what I told you, byproduct will be here CaCO3. So remove CaCO3. What is the remaining part? CH3, CO, CH3. Acetone is your product. That's it. Okay. Reduction table, do you remember? Yesterday's reduction table. Evening study hour time we have did. Once open it. So what are the suitable reagents that we have for reduction of carboxylic acids? Lithium aluminium hydride, B2H6, H2 metal. Okay, so what is the products formed here? Respective alcohols will be formed. Okay, the table is very, very important. Okay, but if I use sodium borohydride, is there any use here? No use. So it will not do this reaction. The selective reduction we can say. I mean, sodium borohydride is a weak reducing agent. It cannot reduce carboxylic acid. It can only reduce aldehydes, ketones, acid, halides. Okay, right. The next one. See, in hydrocarbon chapter we have studied something like this, whether it can be alcohol, whether it can be aldehyde, whether it can be carboxylic acid, or it can be ketone. Upon treating with HI, with red phosphorus, what is the product formed? Respective alkanes. Remove this, complete this OH groups, everything. How many carbons are there? Make that much alkane. Look, for example, it is ethanol. C2H5OH. What is the answer? I am saying it can be alcohol, aldehyde, carboxylic acid. What is the product formed? Respect to alkane. See, if it is ethanol, ethane. For example, it is acetic acid. There is nothing like acetane. Acetic acid, how many carbons? Ethanoic acid means you will get ethane. But acetic acid means what? Ethanoic acid like CH3COOH. So now what is the answer? Ethane. CH3CH3. Okay. See what you are doing? If there is a carboxylic acid, treating with HI converts into RH. Okay. Like even this carbon also counted. Here it means, like here you are seeing now, how many carbons you are seeing? Get respective product. That's it. Yeah. Next reaction is HVZ reaction. I think you studied for your exam. What happens? Tell me. Choice. Okay. Very simple. See, to this carbonyl group, to this carboxylic acid, adjacent carbon, what we should call? Alpha carbon. No? On alpha carbon, hydrogen is replaced by halogen. What I am saying? On alpha carbon, hydrogen is replaced by halogen. So you are treating with bromine red phosphorus now, Br2 red phosphorus. So what it will do? Remove this hydrogen, one hydrogen, replace with bromine. That's it. So what is your answer? Br. That's it. So alpha halogenation of HVZ reaction. Hell-Wola-Zelensky reaction. What happens? Alpha halogenation of carboxylic acids takes place using what? Bromine red phosphorus. Okay, that's it. Next. You left this for choice. Easy only now. No need of writing mechanism, anything. Now tell me this one. Where the reaction takes place? Yes. Where? అక్కడ ఇక్కడ కాదు, నెంబర్స్ అందుకే ఇచ్చింది. That, so what I should write? Br. Okay. So sir, what is the use of this HVZ reaction? Means, you know, amino acids. Simply I give you carboxylic acids. I am asking you to convert into amino acid. Now what you do is, first step, convert into this alpha halogenated product. Now treat this with ammonia. Treat this with ammonia. So now what happens? In the place of bromine, NH3 will be substituted, like NH2 it will be. So finally COOH, and here NH2. See, alpha amino acid means like this only, na? Some R group will be there this side, some alkyl chain will be there. Like this. So for example, alanine, what is the formula of alanine? Alanine. You don't know, I mean, see, alanine, this is alpha amino acid. Anyways, we'll do that in our class. Okay, so what is this? Alanine. Alpha amino acids, you know, na? Glycine, alanine, valine, leucine, essential, non-essential. This one is alanine. So now see, alpha amino acid it is. So we can prepare this using this HVZ reaction is one of the intermediate reaction we can say. Okay, don't think why we are studying all this reaction. If you want to do any of these important products, we may use this intermediate reactions. Okay, next. Okay, take break.